Did you want me to add that guy, or did you never email him back?
He never emailed me back.
Hi.
Hi, Amanda. Can you hear us?
Yes.
Okay, perfect.
Did you guys get a text message from David?
Yes, Andrew did.
I did, yeah.
Okay, cool.
So we'll just get started, I guess.
Okay.
Okay.
We also got an email from some guy that wants to enter in our group. Join our group. But I think it was just sent to me and David. He didn't send it to anyone else. I didn't see.
Yeah, I didn't get an email.
Yeah. Anyways, I sent him the days of when we meet and told him that we meet tonight, but he never emailed me back. So I don't think he's coming.
Okay, maybe he'll start next week when we're back on regular schedule.
Yeah, maybe. So we'll see how that works.
Okay.
Okay. So, were you able to finish the review?
Yeah, most of it. I got kind of stuck on 11, 12, and 14, but I think I figured it out. I had to use that one Excel sheet.
Okay, yeah. Did we get stuck on this one?
We got stuck on 10,
Sorry, I'm gonna just move this here so I can see it.
And then did we want?
We didn't.
We didn't really understand the last probably 12 questions.
Yeah, same here. So.
Any others that you were struggling with other than those ones?
No, all the beginning ones, like I got 1 through 11. I got.
Okay. Well, let's just quickly go over them just so that we have the same ideas, making sure that we got the same answers. How about that? So the first one, we got central limit theorem.
Yep. And then second one, law of large numbers.
Okay. And then the third one was just the number 1.
I put number 2. Because I think the first one would be quantitative because it's not specific. I went back over like the definitions for like quantitative and categorical.
Categorical?
Yeah. Categorical.
Yeah.
That's what I meant. But I think it would be the second one because categorical, it can only be one. Like the example it gave was like questions that are yes or no. So then if you picked a certain toothpaste, then it's more, there's like different categories of toothpaste. I don't know.
So
I was kind of confused about that one.
So categorical is oh, maybe that's what I messed it up.
Non-numerical.
Okay, so categorical is non-numerical.
Yeah,
and that's why I got confused. Okay, so categorical is non-numerical, quantitative is numerical.
Right.
And I was thinking, okay, so I got confused. X, gender, class in college, a randomly selected brand of toothpaste at a convenience store.
Yeah, so 2 would be right.
But 2 would be right, but so would age in years of a randomly selected vehicle in a large lot.
I think no, because of the age, because age is like numerical.
Yeah, number.
So, but then 2 is the only one not associated with
numbers, yeah.
Age in years of a randomly selected vehicle in a large. Okay.
Yeah, I think 2.
Okay. 2.
Okay, so yeah, where were we at?
I don't know.
Okay, so 2. And then
for number 4, I put the statistic as 100 and the parameter as 112.
I got them back. I did them the other way.
Okay. I put it like that because when I looked at the definitions, it said statistic was like a computed numerical fact, and then a parameter is something that's like a possible value. And so 100 was the IQ score, so it was like, it's like the fact of the score, the IQ score in the United States, but then 112 would be a possible value.
Okay, so it says a parameter is a true but usually unknown number that describes a population. And a statistic is an estimate of a parameter obtained from a sample. So the question was,
the mean score. It says the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their score was 112.
so I think the reason I put it is because it said a statistic is an estimate of a parameter, and then they tell us 20 randomly selected students or selected statistics students took an IQ test, and the mean of their scores was 112. So hold on a second. The mean IQ test score in the United States is 100, which is usually unknown parameter. It's true, but usually not a number that describes a population. So that describes the population.
I think somewhere in the book I was reading it said statistic is like more of a fact, like a computed fact. So,
Okay.
parameter. I'm not sure.
A statistic.
The mean score is 100.
So the statistic is an estimate of a parameter obtained from a sample. Parameter is a true but usually unknown number that describes the population. So I put it because the reason I put 100 is because that was the number given from the population of the United States. The mean IQ test score in the United States is 100. That's why I put parameter.
Mm-hmm.
And then a statistic is an estimate of a parameter obtained from a statistic comes from the parameter.
Oh.
A statistic is an estimate of a parameter, and then the question was, it says 20 randomly selected statistics students took an IQ test, and the mean of their score was 112. So
okay, so the statistic comes from the parameter.
Yeah, statistic is an estimate of a parameter obtained from a sample.
Okay, that makes more sense then.
So let's see, an estimate of a parameter obtained from a sample. 20 randomly selected statistics students took an IQ
Well, I think that would be the sample. So yeah, it makes sense.
because they're.
So then, since the statistic comes from the parameter, then the parameter would be 100 and the statistic is 112?
Yes.
Right?
Yeah.
Andrew looks confused.
I am confused. It made really good sense to me the first time I was reading it.
Well,
but I mean,
100
still says, because that's from the population of the United States.
Right.
That's what the parameter is. It's not usually known number, but it describes the population. The mean IQ. No.
But then, but if the statistic comes from the parameter, then 112 came from the 100.
Right.
Because it was based off of the 100.
Yeah, and I was just reading again, but it doesn't. I mean, it comes from the population, but it's selected not from the population, but from statistics students.
Huh.
So yeah, I think
I
I
don't
think
know.
yeah. I
Does
think the
that sound good?
parameter. I mean, looking at it, I think the parameter is 100.
Okay, let's keep
Okay.
going.
Okay, so 5. Did you want to read that into?
Okay, 5. Rotham City has 4 distinct neighborhoods. The property values, I don't know if I want to read them. I'd rather just go.
Yeah, can we just read the answers?
Yeah, that's going to go. So 5, I put simple random sampling.
I put stratified random sampling.
Stratified.
Yeah, because they were grouped according to a similar income level. Like the other example of stratified random sampling was when they had like the freshman, sophomore, junior, senior. And then this one, they're grouped according to their their income, like their property values.
Oh yeah.
Kept 6. Yeah, those were, what does it say there? 3 or 2?
Less than 2.
I don't know. I get confused. I mean, simple random sampling is the most simple one to me, but I don't know why it has 4 distinct neighborhoods. Okay, because it has 4 distinct neighborhoods. The property values are very similar. So that's why, because it has, wait, property values are very
Wait,
similar.
what did you put for 5?
Simple random sample.
Oh wait, simple random sampling is like drawing from a hat or using a computer.
Yeah. It's a random selection from your population.
So no, that wouldn't be it. She's right.
That's why I'm at. So I just want to. So let's see. The property values are very similar within each group, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another extreme. Okay, so yeah. Divides the 2 datas into 2 groups, and then they take a randomly split.
Yeah.
Yeah. Okay. Yeah, you're right. And then 6, we had. I didn't know if it was stratified or cluster. If I
I
don't.
put cluster because, let's see, they chose a group to represent the population. Like, so they chose teachers from 4th grade, but then they didn't. So it was out of like a whole school, but they only did 4th grade, but then they did all the students that were in the 4th grade. So it's like representing a small group in the population.
Okay.
So
yeah.
whenever it's a clusters or blocks, it's within the population, but it's a small, like a block of the population, like the 4th grade, like, right? Is that what you're explaining?
Yeah.
Because
So
it's the
they used like all the teachers in 4th grade to represent all the teachers in the school.
Okay. Yeah.
So it's
okay.
like, yeah, like there's like a small population used to represent a bigger population.
Okay. Perfect. And then, so you circle that.
Yep,
Okay.
yeah.
And then 7, I did simple random sampling again.
Yep, that's what I got for 7.
Okay. 8 was stratified.
I put systematic.
Systematic.
Because it was done with some kind of sequential order, but they chose, what did they do? They chose the Democrats randomly, but then after they did the Democrats, they also did the Republicans.
See, and that's why I did it like you were saying for the first one. Is because they divide them into 2 groups, like they did the neighborhoods. They did a low property values and a high property values of the above, and then
but then number 5 is a little different because it's according to income level. But then number 8 is just according to like 2 different groups. I saw the definitions of each of them. So.
yeah, so they're right above. Yeah, are you not getting your review to pull up of like the right above all the questions? There should be a thing right where it says your 2 review questions on number 1. there should be a thing that says show summaries to the
Oh,
right.
yeah, I see that.
Click on it.
Shows. Okay, so systematic.
So go up to lesson 2, I think. Lesson 2 recap.
Right. So then,
See, systematic would be systematic, or is that what you said it would be, is systematic?
yeah, for number, wait a second. I think I got those two mixed up. Cause then, wait a second.
So systematic is like they're gonna do random random starting point when someone enters into like a building and they were wanting to do a survey of people coming into like a class. They would say, okay, let's randomly pick the 15th person, and from that 15th person, then we will choose every third person. So then
Yeah.
18, 21, 24, 27, so on. And so that's why I don't think that one's systematic. I think it's stratified sample because it divides data into similar groups. Just like you were saying, it divides the Republican Party and the Democratic Party, and then it
But then within those, then it selects a simple random sample of the 100 people.
yeah, and that's what it says. So it says.
So then 5 would be systematic and 8 would be stratified.
Each group.
Mm.
So, okay, so hold on a second. So it says stratified sample divides data into similar groups, and then simple random sample is taken from each group. So what they do is they divide the groups, says, to adequately gauge opinions on both sides of the political spectrum. The researchers took the list of registered Democrats and selected a simple random sample of 100 people. So that's of the one group, and then they took a list of registered Republicans and selected simple random sample of 100 people from 2 separate groups.
Okay, so then 8 would be stratified, which would make 5 systematic, right?
I don't know. I still think that 5 would be. I still think that you're right on 5 because the property values are very similar within each neighborhood, but they are very considerably from neighborhood to neighborhood. One neighborhood has a very low property value, and another is extremely high property value.
Yeah.
Property taxes are usually roughly proportional to property values. What type of sample should we collect to gauge this residents' responses to a proposed increase in property taxes? This one's a little different because it asks it's asking what type we should collect for certain information, whereas the other ones are telling us what type of sampling they did use. 5 saying what type of sampling should we collect to gauge the residents' responses to a proposed increase in property taxes.
Mm-hmm.
Maybe 8 is convenience.
Convenience is what usually obtained in a less than systematic way and should be avoided when possible. I don't know. I think it's I don't know.
Convenience sample, because that's less than systematic way. So because they just did Democrats and then Republicans, so it wasn't really organized that well, and it seems like they
took a simple random sample of 100 people from the 2 groups, from a Democratic group and then from a Republican group. See, that's less from systematic. We said it was stratified. Yeah, we said it was stratified.
Huh.
Maybe we just put a star on this and make sure we review it before we do the test, just so that we all have pretty fresh in mind what that one. So put a star in.
Yeah, I did.
Yeah.
So make sure that we review that. That's what we'll do. So let's see.
The mean.
9 and what'd you get for 9? You got those one?
Yes, I got the mean 4.771, standard deviation 1.912, and then 5-number summary, minimum 0.84, quartile 1 3.42, median 5.15, quartile 3 5.61, and maximum 10.45.
Okay, so I think, what did you say for the median? Or wait, is it the median or the mean?
Median.
Is it the mean or is it the median?
Because 5-number summary goes minimum, quartile 1, median, quartile 3, maximum.
It doesn't ask for the mean?
The mean was the first, so it asked for mean, standard deviation, and then 5-number summary.
Okay.
Did you find that using the SSPS, whatever that's?
No, I used Excel.
How'd you get the quartile 1 and 3?
That's in Excel. Like, it's called the quantitative descriptive statistics.
Okay.
And if you enter in all the numbers to the left of that Excel document, then it just has a table that automatically puts in the mean, standard deviation, variance, and then the 5-number summary.
So if I open the Excel,
and
then what do I click?
Wait, do you have the quantitative descriptive statistics document?
You're getting ready to open it up.
Yes.
Yeah, she's getting ready to open it up. Here.
Okay. Let me plug my phone in real quick. It's about to die. That's what I'm using for this.
Okay, yeah. Okay, so I have the crossroad purchases open.
Okay. So, do you have the quantitative descriptive statistics?
I don't think so, because I use the SPSS system, and I wasn't able to figure out how to get the 5-number summary on that.
Oh, because I didn't use that. That was too confusing for me, so I just been using Excel.
So you have to download the descriptive thing?
Yeah, I think, what lesson was this in? Lesson 3?
Yeah.
So if you go to iLearn and then click on the book for lesson 3,
Okay.
then there should be a link. Let's see. Yeah, so it should, so in the book in lesson 3, there should be, like, it goes to, like, blue sections and shows graphs, and it says Excel instructions.
In lesson 3.
Individual preparation?
I don't know.
Did you say individual
Yeah,
preparation?
individual preparation, then click on the first link that says describing quantitative data, shape, center, and spread.
Okay.
And then go down past step 1, step 2, step 3, and then you see graphs, and then there's a blue section that says Excel instructions.
Oh, okay, yes, yes.
Then under that, in that blue box, you can click on the link that says Quantitative Descriptive Statistics,
Keep going down.
and then it takes you to Excel tools, and then click on Quantitative Descriptive Statistics, and that should open up the Excel document.
Is it a link?
You're in that. It's. I think about that. About. Keep going.
She said below that there's an Excel sheet.
Did you click on Quantitative Descriptive Statistics?
I can't find it. So I'm
We just
at,
see the SPSS instructions.
it says,
So
it
right
says,
above that one, it should say Excel instructions.
Keep going.
I'm at 3.1 visualizing quantitative data. Histograms.
Visualizing
We'll
quantitative.
figure it out because I've been using the other one, but I think Excel would be easier, so we'll have to figure that out. We at least know
Oh,
where.
so if you're at 3.1, just go a little bit more down, and then there's a blue box that says Excel instructions.
Yeah.
So inside that blue box, it says instructions for grading a histogram. To make a histogram, and then it has quantitative descriptive statistics. It should be a link, and then you click on it.
Okay.
Okay. It's not pulling up the blue box, but I think we'll figure it out someday.
Okay. And then use the histogram, right? We didn't have to do it to write anything.
Yeah, then 10 was just the histogram. I just did that in Excel.
Okay, yeah. That's what we did it on that SPSS. And then number 11, we got, okay, 11, X bar equals 38.075.
Wait, for 11?
No, so the answer was, so for A.
Oh, A, right here.
Was negative 0.165.
Yes, negative 0.165, right.
Yes. And then B, for 12, B was
0.680625.
Wait a second. B. So, wait a second.
So I took the number 37.25 that they gave me.
So for like before being next to it for the deviation from the mean for Roberta, did you get negative 0.825?
Yes.
Okay.
Negative
then you square it.
0.825, yeah.
Yep, but then you square it and you get 0.680625.
Okay.
Because in that question it says.
So your answer was 0.681. I think I rounded it.
Yeah, 681.
Yeah.
Okay.
Okay, and then we couldn't figure out number 13.
Yeah.
Number 13, I think it was none of these is correct because
We were thinking that because it doesn't equal the mean and the standard deviation and the variance, and yeah, so we did D, but we weren't sure.
Yeah, because I don't think it is any of those other three.
And then for number 14, we got 0.715.
That's what I got.
And then 15 false.
Under these conditions, the standard deviation, yeah.
Okay, and then 16
is extradural.
16. To which location resulted in the most consistent temperatures from one seal to another? How did you guys get that? Because I was confused on that one.
Well, because it has the lowest standard deviation.
So
It's going to be...
So your sample sizes are all small. They're all going to be, your sample sizes are all small, and your standard deviation is the smallest for that one. So using your, whatever theorem it's called, where your what's my reading at?
Was it, wait, the large thing? What was it called?
Yeah, when your standard because your standard deviation is the smallest.
Small. Then
why can't I think
Is that the law of large numbers?
Yes. Yep.
Okay.
Yeah, using the law of large numbers. Because, well, now I'm double guessing
no,
myself.
I think you're right. Because
Yeah.
the smaller the standard deviation, the closer you're going to be to
Accurate.
accurate.
Right.
And the question is which location resulted in the most consistent temperature measurements from one scale.
Yeah. So,
Okay.
okay, and then 17, what did we get for that one?
Okay, so number 17 just asks you to explain what the standard deviation is. And did you write down a definition in your own words?
Wait a second. What lesson was that from?
It wasn't a lesson. It is from a lesson, but I don't know. It is from a lesson, but it just wants to give you he wants you to define what the standard deviation is in your own terms without using statistical jargon and telling how to calculate it. He just wants you to know what does the standard deviation represent by explaining it. So let me read to you my definition of it to see if I understand what it is, and you can tell me if it makes sense.
Okay.
So if I'm trying to explain a standard deviation to someone on what it is, I would say it is the number that represents the distance between many outcomes. That's all I would say. To give my example of that, I would say, for example, you have many outcomes of grades. Like I have 30 students, and I have all those 30 students get a grade of, I don't know, 80s, 85s, 85, 90, 95, 100. So all of their outcomes, the standard deviation represents the number between other outcomes.
Okay, that makes sense.
Okay. So the standard deviation is the number that represents the distance between other outcomes. Yes. Yeah? Okay.
Yeah, that makes sense.
So then number 18, for the five number summary, we got 2, 4, 6, 8, 12.
Right.
And then what percentage of the data lies between 4 hours and 8 hours? 50%.
4 hours and 8 hours. Right. Because it's 4 to 8. Okay. 50%.
And then we had the hardest time with pretty much the rest of it.
Okay. Estimate the mean of the measured nitrate concentration in experts drinking water. What percentage of the data? Okay. Observation. Maybe we should just read that.
Oh,
the observation.
Okay. I'll read it. It says, an observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from If it is more than 2 standard deviations away from the mean, there are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52. And values outside of this range are unusual. We will assume 1.59 is the value of all that stuff, and is 2.52. It is reasonable to assume that the measured nitrate concentration is normally distributed. Use the information to answer questions 20 through 22. So the question is, estimate the mean of the measured nitrate concentration in Rexburg's drinking water.
Okay. So we know that it's normally distributed. Have to estimate the mean.
I don't know.
Yeah.
Due to health risk.
Does it even give us the mean?
Well, it's asking us to find out the mean of the measured nitrate concentration. Estimate the mean. Estimate the mean of the measured nitrate concentration.
So it said that the water supply is between 1.5 and 2.52.
Mm-hmm.
Values outside this range are unusual. So
Estimate the average of the measured nitrate concentration in each. So if it is, and the city's drinking water supply is between 1.59 and 2.52, you would take, to find the mean, would you just take 1.59 plus 2.52 and divide it by 2?
that's what I was thinking, because those are really the only numbers it gives us, so we can't, because we don't have like a set of numbers to use other than those two to get a mean.
Yeah. Close.
0.59, 2.52. 0.59, 2.52. So then that would be 2.055.
Yeah. So could we use Excel for all this then? If it's asking now for the standard deviation and between the two measured concentrations?
Yeah, we could. 1.59, 2.52. 1.59, 2.52. So then, if we use Excel, just using those two numbers.
Three numbers now because we know the mean.
Right. So
Yeah.
then it would say the standard deviation would be 0.658.
Okay. Let's see the number.
That's just using Excel.
Okay. And then let's see. So 22. Between what two measured nitrate concentrations do approximately 68% of the data values lie?
So that would be from the 25, 68, 95. Or no, that's 65.
Oh, yeah, that's true. So then standard, then it would be 2.055 plus or minus 0.658, right?
Yeah, I think so.
What? 2 point. What?
Because the mean is the middle, and the standard deviation is how, like 68% would be one standard deviation away from the mean, right?
Yeah. Yeah.
Explain that one again to me. What you just said. Say it again.
So the 68, 95, 98 rule. So 68% is 1 standard deviation away from the mean. 95% is 2 standard deviations away from the mean. Then 98% is 3 standard deviations away from the mean.
Okay.
So then if we're doing 68%, it would be 2.055 plus or minus 0.658.
Minus 0.658?
Yeah, 658.
Okay, I see what you're saying. I need to freshen up on that roll.
Yeah, me too, though. Minus 0.658.
1.397?
Yeah, that's what I got. 397.
Okay, so let's see if I got that. So the mean is 2.55 using the 68, 95, 98?
Yeah.
Yeah.
So using that rule, 68 is 1 standard deviation away, 95 is 2 standard deviations away, 98 is 3 standard deviations away.
Yep.
Yes.
And for every standard deviation away, you just add the standard deviation.
Yes.
Okay, perfect. 23. What is the mean and standard deviation of the standard normal distribution?
Wait, so then I have a question for 22. Would there be 2 answers because 1 standard deviation could be plus or minus?
Mean what?
Well, standard deviation can't be negative.
Right. But whether you add or subtract, it's still a positive number.
Because it's asking between what two measured nitrate concentrations do approximately 68% of the data values lie. Well, it is asking for 2 numbers. So between what two measured nitrate concentrations do?
So yes, we do need to do a minus 2.
Not minus 2.
Well, minus as well as we added. Did we add?
Well, we subtracted,
No,
so then, because we got 1.397, so then
We need
it
it.
would,
No.
the other one would be 2.713.
So between what two measured nitrate concentrations do approximately 68% of the data values lie? So 68% of the data value is, we figured, at 1.397, right? So that's
Right.
60% of the value. So what numbers?
What 2 numbers?
What 2 numbers
Yeah,
is
that's
it
what we're
between?
getting, Andrew.
What 2 numbers is it between?
We have this one, and now we did the minus. Now we need to do the add, and they're going to be
So
in
this
between.
this one's the first one.
Because here's the mean, and then you go 68 this way, so they're going to be between these. So they're going to be between 1.397, and what was the number you just got?
2.713.
So 68 of the data lie between these.
2.055. Or
68 of the data.
Because you have to subtract the standard deviation and then also add the standard deviation from the mean to get the 2 points.
Right. So you add it, you subtract it from the mean, and then you add it to the mean, right?
Yes.
Okay. Okay. Yeah.
Okay.
Good job.
Thanks.
Maybe read that correctly, because I didn't. Let's see. What is the mean and standard deviation of the standard normal distribution?
Wait, then now we're on 23, right?
Yeah.
What is the mean and standard deviation of the standard normal distribution?
Mean and standard deviation of the standard.
I always get me so mixed up when they use like the same words and for different things.
Wait, wouldn't it just be the same as what we got for 20 and 21? Because it already said it's normally distributed?
I don't know. I don't understand the question. What is the mean and standard deviation of the standard normal distribution?
I
So
would
the
think
standard
so.
normal,
I,
so the standard normal distribution is just what they're asking of the distribution of the population that's in the bell curve.
Yeah.
That's the standard normal distribution, right? So it would, yeah, so it would be the mean and the standard deviation. Is that what you're saying? Is just the numbers of 20 and 21 the answers? The mean and then 21 is the standard deviation?
yeah.
What is the mean and the standard deviation of the standard normal distribution? Yeah, let's do it. I mean, we're not getting, I mean, this is just review, so we really need to get to the quiz.
Yeah.
But I think you're
Yeah.
right.
But I think when I looked at the group quiz, it said that the group quiz was the same as this homework.
Oh, it is?
Oh. So
I hope it is.
yeah,
I know.
that'd be nice, because then, yeah, that would be nice.
I was just thinking, we're going to be here for a whole nother hour.
I know.
Okay, so write down those, because I think that's right. What is
Okay.
the mean and standard deviation are
I'll just put a star next to it on my document, just in case.
Okay, and we had a really hard time with number 24 because we couldn't figure it out when you minus, it was the same number as the value. The mean was the same number as the value we were trying to figure out.
Wait,
Tell us when you're ready for 24 and we'll read it.
okay, 24. Okay,
You ready?
yeah.
Okay. The admissions committees for most Masters of Business Administration programs require the Graduate Management Admission Test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the whatever that is program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. Use this information to answer questions 24 to 32. What is the probability that a randomly selected student will score above 542.3 on the GMAT?
Okay, so we have to use, I think we used that equation in last week's lesson. What lesson was that?
Yeah.
Yeah,
So wouldn't we minus 542.3 minus the mean divided by the standard deviation?
Wait a second. Let me,
It was a lesson to find the z-score.
yeah. Was it lesson 7, the lesson before this one?
Looks like lesson 6.
Lesson 6.
Or maybe even lesson 5. Yeah, it's actually lesson 5.
It's lesson 5.
Okay. Lesson 5.
It was the value minus the mean divided by standard deviation.
Lesson 5.
So it's 68.95, 99.7.
Wait, so what equals, it was x minus mu over standard deviation, right?
Yes.
Yeah. Yeah.
Okay.
So we
So,
calculate to find out the probability.
we have to find the z-score and then use the applet, the normal distribution applet, to find the probability.
Yes.
So, let's see, we would be doing 540, or wait, no. What was the less than 600? So we're doing 600 minus 542.3 divided by 120.54.
So, but what are you?
That one's for 25?
Yeah, right?
So,
Because the mean
yeah.
is 542.3, standard deviation is 120.54.
Yeah.
And we're trying
See,
to figure out.
I think the first one, though, is 24 because the value that we're looking for is the same as the mean, so I couldn't figure that out. But you're right on number 25.
Oh, that would be for number 25. But then, for number 24, would it just be the mean divided by the standard deviation then?
I think we tried that, and then it didn't equal out right. Like when we entered it in the applet, it didn't do anything. But let's try it again.
Okay. Let me pull. What lesson was the applet in? Do you remember?
The easiest way too is if you Google probability applet BYU Idaho, it pops it right up.
Okay, probability applet.
And then just make sure to put BYU Idaho.
Okay. Oh, okay. Got it.
So I think it has to be like a pretty low. Yes, please. A pretty low decimal in order to work on the probability, because anytime you divide the mean by 120, it's like 4.4 something, and then I put it into the applet and it doesn't come out normal. But you try it, see what you get.
Yeah, I got 4.4. Oh, 4 point. I guess it would be 4.500. Oh, 4.0. Yeah, because then that wouldn't be normally. I think that would make it not normally distributed.
Right? Yeah, so I don't know how to figure it out. We were
Maybe it's. Let's see. What does it say? The minimum GMAT score is, maybe we need to do 500 minus 542.3.
Yeah.
Because that's the original 42.3. Because it says that the minimum score required is 500, but so maybe that would be X. So then 500 minus 542.3 divided by 120.54. Because then
She did 500 minus 540.3 equals divided by 120. Yeah.
Because then that would be 0.351 for the z-score.
351. And then it's wanting to know we'll score above.
Above what?
Above this negative.
So then we'd just be shading to the right.
And the middle, because it's a negative number. Like I got
Oh.
-0.3, -0.351. So I think even like anything positive would be right. I could be wrong.
Point six.
So did you get .637?
Yeah.
Okay.
0.6. That's shading in the middle and the right,
Yes.
correct?
Yes. Yeah.
Okay.
And then you had it exactly right for 25.
Okay.
600 minus.
542.3.
Yeah. Divided by.
So you get a negative number divided by.
Well, for this one we got a negative number, but now we're on.
7.75 by.
Okay. 600 minus 542. Did you already do it?
Yeah. Remember we got these. I just need to see.
Oh.
We got those. We did 25 and 26.
So then for z-score for 25, did you get 0.479?
Sorry, hold on. We had already just did the probability, but let me make
Oh.
sure. Sorry, so did you get .479?
Yes.
Yep. And then you plug that in, and I think for number 25, it's wanting to know below.
Let's see. Right. So then we just shade to the left, and it's 0.316.
Yes, and then it wants to know above that too. So would we just minus one? Is that, do you remember that rule?
What's the probability? Yeah, because if that's less than, then above would be just 1 minus 0.316. Which would be 1 minus 0.6. 0.684.
Yep, that's what we got as well.
Okay.
Okay, and then 27 says find the GMAT score that corresponds to the 10th percentile. I didn't know how to.
I remember doing that, but I don't remember how we did it.
How do you do that?
That was from last week, too. Let's see. Percentile.
We almost have. Don't you have to make a bell square or a bell?
Here we go. It was from lesson 5. So yeah, you have to. I think you have to use the probability applet again. But
Yeah, and percentiles, yeah. It says to calculate proportions, probabilities, and percentiles. Since we're trying to find out the percentiles, but where do you plug in the? Would the 10th percentile be the our
the what?
The n where you would your what's the n?
N is the sample size.
Yeah.
That's not. That's when.
No, but it wouldn't do anything. I thought maybe that you. Look up Google just how to find 10%. Mama.
Oh, wait a second. Find the GMAT score that corresponds to the 10th percentile. So I think you put 0.1 in the area, right?
Oh, yeah. Because that'll be 10 percentile. 10%. So point one. Point one.
No.
0.01. 0.01?
Wait, no, 0.1.
0.
Because that would be 10%.
Yeah.
So then we get 1 point, and we're wanting.
That corresponds to 10th percentile, which would you use your
I don't know. I get 1.282.
Yeah, that's what I got.
Okay. And then we would do the 90th.
So then 0.9. And then I got...
That's the same thing.
Wait, that's the same thing.
Yeah, you gotta plug in
What? You can't plug in two things. You can either plug in the area or you can plug in the z-score, but you can't plug in both.
Every time I try to put 0.9, it shades in the middle on the left.
Yeah, and then you get the same thing, right?
Yeah. Maybe it's... Wait, no. That wouldn't make sense. I think we have to do something with that number. There's something else we have to do. Because that's just the z-score.
And GMAT score that corresponds to the 90th percentile.
Scroll up and see the same thing about 90th or 10.
That's what.
Okay, go to the book and actually go to chapter 5 in the book.
The 10th percentile.
Yeah, that's there. 10 plus 5.
Solution. So then, oh, that's when we have to switch the equation around. We have to do z-score. We have to do x equals mu plus z times standard deviation. Plus z.
Right here, something right there.
Especially find the score that corresponds to the 90th percentile using the normal probability operator. Click the areas in the curve until only the areas left of the positive z-score are shaded blue. So do that. Positive. It says click on the areas under the curve until only the areas left of the positive z-score. So yeah, that's it. Left of the positive z-score.
Yeah.
Okay. Are shaded blue. Type the desired area or percentile in the box at the top of the graph. Type in number between 0 and 1. The 90th percentile would be entered as 0.9. So do 0.1 and then 0.9. Is it the same thing? That would be 0.1. 0.1.
Yeah, this is the same thing. It's even the same thing there.
Except for they changed the shades because this would be 90th percentile.
In the book, it even has the 90th and the 10th percentile the same.
Really?
So
Yeah.
Z equals 0.282 is the z-score that the first one is the 90th percentile. And normal distribution, how do we find the value
watch your show.
corresponds to the 90th percentile? We can solve for x. Yeah, so we do what you said. So we solve for x in the equation of the z-score.
Okay.
So
So
x
we have the
minus mu
z-score.
equals z. Z equals x minus mu, or the standard deviation. We know z equals that, and mu equals.
So we do the equation you were talking about and try and find x, right?
Right.
We know x, and do we know the standard deviation?
We don't know x.
We don't know x.
No.
But we do know mu.
So then we'd be doing, so the mean is 542.3. So then we're doing that plus the z-score, which we found is 1.282. And then times 120.54.
So yeah, so you go
Right here.
so 5.4.
5.42 is mu,
No. Like, yeah.
which is the mean, right? I never remember.
I got 6. Whoa.
Wait a second.
I didn't do that right. Hold on.
Mu is the average. Okay. Yeah. So 542 minus 0.3. We do what you said, remember?
Yeah, but I gotta add this over here, right? And then I gotta times that, but that would make that way big.
No, remember, you made it really easy the first time.
Did you find a number yet?
No.
Right here. So you times it by that, so times that by that.
Okay, so 1.282 times.
Okay, so write it down like this now. And then x minus 542. Oh wait. Actually, you don't do those together, do you? Don't do this together yet. Maybe you do. Oh, and then you add it.
So I got 696.83, but that's way higher.
Wait a second. 542 point. Okay, 542.3.
Oh, no, it's normal, because it says, I thought it said. Okay, so it says that the admissions requires 500, but it's rare with students less than 600 to be admitted. So, yeah.
Wait, so I got 696.832.
Yeah.
Okay.
And was this for the 10th or the 90th?
That was for the 10th percentile. But then, did you say the book showed them as the same thing?
It showed the 90th percentile is 1.282, which was just the That's how it showed how to get the 90th, was to use that. So how would you get the 10th?
It's fine.
Okay.
Wait. I think the 10th percentile, the z-score would be negative, and then the 90th percentile would be positive.
I think you're exactly right.
So we just did it for the 90th percentile.
Yes, so now we need to do it for the...
Now we need to do it for the 10th percentile. So then it would be, instead of plus, it would be minus 542.3 minus 1.282. So 542.3 minus 1.282. One point. Wait, no.
So, and then you just add that. Well, I don't know how to do that. That plus.
Did you get
387.
387.77?
Wait. So then it would be 542.3 minus 154.53228. So I got 387.768. Is that what you said?
Yep.
Okay. Awesome.
Okay. Now 29. Find the first quartile of the distribution of the GMAT scores.
Point.
The first would be the 25th percentile. So type in your 0.25 and the probability output.
Wait, first quartile of the distribution of the GMAT scores. So what are we using as GMAT scores? That's just going off of...
The first quartile is the 25th percentile, so we're just trying to figure out the same thing that we were just doing for the percentages, right? For the percentiles of the 90th percentile and the 10th percentile. So
then
2.5 to the area.
0.5.
But which one do we shade? What's the question?
Wouldn't it not matter because it's 50%? We just shade one side? But then it shows z-score as being 0.
The first quartile is 25%. What do you shade?
Yeah, and the normal probability applet.
Yeah, what part do you shade?
Don't you just... I don't think it matters if you shade left or right because it's 50%.
What do you mean it's 50%?
If it's the 50th percentile? I don't know, because when I put 0.5 in the applet, it goes straight in the middle. And then
not 0.5, 0.25.
Oh. Right, okay.
No,
That's why.
There.
Okay, so wouldn't you just shade to the left?
Well, then it's the same thing. The z-score is the exact same.
I got a z-score of 0.674.
By
By just shading the left and the area is 0.25.
Okay, there we go. Yeah.
Okay. So the z-score is 0.6. Did you get 0.674 for the z-score?
Yep.
Okay.
So we're still using the same
Same
540,
equation.
120, 54.
But then, since it's 25%, would we be subtracting or adding?
We don't do anything different.
But like for the 10th percentile, we subtracted, but then the 90th percentile we added. So
what I did is I just multiplied the z-score by the standard deviation. So point, right?
right, but for the z-score, did you do negative z-score?
Yeah.
You did do negative.
Right there.
Yeah, but that was for the other one. Are you doing it now?
Am I doing negative now? Is that your question?
Yeah. For number 29, since it's 25th percentile, we'd be doing negative z-score, right?
I don't know.
Because for 10th percentile, we did negative, but then for 90th percentile, we did positive.
Okay. Yeah, I don't know which one, what you did. Yeah, you would use because it shades it to the left side.
Yeah.
Because it shades it to the left side, saying that that's the 25th percentile.
Okay.
So yeah. Okay.
Okay. 0.674. Probably 42.3 minus.
So I got, let's see.
I got 461.056.
That's what I got.
Okay, cool. So then the third quartile would be 75%.
Oh, sorry. Okay, go again. What?
So then for 30, we have to find the third quartile. So would that be 75%?
Yes.
Okay. So then this time, we'd be shading in the right. Wait. Or I think we'd be using the same z-score, but then doing positive.
Yes, you shade the middle too.
Yeah. Z-score. Okay.
Yeah, so it's pretty much the same thing as the 10th and the 90th percentile.
Yeah. So
You
then
just
we'd be doing
different z-score.
adding.
Yeah, you got to add. Okay. So you wouldn't. Yeah, so you have a positive z-score instead of a negative one, right? Is that what you're saying?
Yes. $42.3.
Okay.
Okay, what'd you get for 30?
I got 623.544.
Yes, that's what I got.
Okay.
Okay.
And then 31.
Consider a simple random sample of n equals 15 students taking the GMAT. What are the mean and standard deviation of the distribution of sample mean scores for all such samples? So, we'd be using whatever we did last week when we used the n.
Yeah, so z equals,
I think that was lesson 6. Lesson 6 or 7. Wait, so
you got
we're
less than
getting...
7.
Wait a second. What are the mean and standard deviation of the distribution sample mean scores for all such samples? How are we supposed to know that if all we're given is the sample size?
We're still using the same numbers that we were given in the question above.
Oh, okay.
Just,
Okay, that makes sense.
same numbers
I
now.
thought it was like a whole new thing.
Yeah, no, not same. So same one, but now he's just giving us the sample size.
Okay. So that equation was what are the mean and standard deviation of the distribution of sample means for all such samples? So the mean would be the same, but the standard deviation would be different. So the mean would still be 542.3, but then standard deviation would be, that would be the original standard deviation divided by the square root of 15.
Okay, so you have z equals what do you have?
Well, we just need to know the mean and the standard deviation. So it's not asking, 32 is where we have to use the z-score, but 31 is just asking what the mean and the standard deviation are. So the mean would be the same, but then the standard deviation is the new standard deviation based off of the sample size of 15. So we would have to do...
You just take 6. You take your. Okay, yeah. That. So you just go. What standard deviation do you want to use? Or
So we'd be using the original one, which was 120.54, and then dividing it by the square root of 15.
okay, that makes sense.
Can we do that one?
15 equals
32. 39.
wait,
Yeah, you're on 32.
Well,
okay. So then For the mean, I got 542.3, and standard deviation, I got 31.123.
Okay, so for the standard deviation, 31.123.
Yeah.
1.123. Okay, and then the mean. Wait, so then you just take you do the same thing we did with our standard deviation. You just take the mean and divide it by the square root of 15.
Wait, are you talking about 31
Yeah.
to get the standard deviation?
Yeah.
So with the equation for the z-score, like they do x minus the mean over standard deviation divided by the square root of n. So the standard deviation divided by the square root of n is what makes the new standard deviation.
Which was 31.123.
Yes.
Yeah, but what did you get for the mean? How did you get that one for the mean?
Oh, the mean is still the same. Because, like last week, when we needed to know the mean and the standard deviation, it said to just use the original mean.
So 542.3.
Yeah.
Okay. And then 32, what is the probability that a sample mean GMAT score for sample random sample of n equals 15 students will be greater than 600? If you remember
So we have to find the z-score first. So that would be, if we're going off of 600,
600 minus 540.
it's 600 minus the mean.
542.3.
Yeah, a 542.3.
So
So
20.54.
542.3
divided by the square root of
15.
So then, since we already got the new standard deviation, it'd be 600 minus 542.3 divided by the 31.123.
Okay.
Okay, so
And then put it into the applet.
right here, yeah. No.
We tried to do it earlier.
5.54. So is this not it?
I don't know. I don't know if we put it in the applet or not.
You don't even put it in the applet.
Yeah, it says the probability. That's just the z-score.
Oh.
So now put it in the applet.
Okay.
Okay, 57.7
And what's
divided.
your z-score?
For my z-score, I got 1.854 rounding.
Okay. And then what do you shade?
Probability. So it's greater than, so you shade to the right. Of 1.854. So what'd you get for your area?
0.0319.
Wait, what did you get?
0.0319.
Okay, yeah, that's what I got.
Okay. Woohoo! We might be halfway.
Yay.
So it's like way past your bedtime.
Yeah.
It's way past our bedtime. We usually go to bed early. Well, we did go to bed early the last few nights.
Yeah.
So let's open up that thing.
Yeah. Let's go to the...
I'll open it up. I open mine up.
So, group meeting, lesson 8.
Whoa! Want to go put them down? Maybe you'll go to sleep.
He won't unless I leave him.
Just put them down this way. Hey, give that kisses. Yeah, give that kisses.
So are you in the quiz yet?
Let's see here. I want to make sure I open the right thing.
Okay.
Lesson 8. Group
Yeah,
meeting.
lesson 8, group meeting.
Oh, good.
Well, you can.
And then start. Oh, press start now. It might open.
And then it skips, from our homework, it skips number 1 and 2 and goes straight to number 3 on the number 3.
And it's the same?
Yeah, it looks the same. The question's the same.
Okay, perfect.
But the thing is, so our homework only had 32 questions, but this quiz has 35.
Because it asked those 3 questions. Right?
Oh, yeah, because it asked those 2 up top.
Well, that would only be 34.
So there's probably an extra one in there somewhere. But since we have the answers written down, we could just do it tomorrow. Submit it
We'll
tomorrow.
save for later.
Yeah.
Yeah, so since it's just the same, we can just do it on our own instead of trying to do it over the video.
Okay. Yeah.
And then tomorrow we're going to do lesson 9 at 9 p.m. Mountain Standard Time.
But if that works. So. Yeah.
We said tomorrow at 9.
Yeah, so I think that'd be 8 o'clock your guys' time.
Does that work? Yeah, that works for us still. I think that's it.
Okay, and then there's not a group collaboration discussion board for lesson 8, so I think just go ahead and post this video in lesson 9 and just label it lesson 8 and make sure you put all 3 of our names in it.
Okay.
Okay.
It's probably just our 3.
Yeah.
Not David, since he didn't show up.
Yeah.
Okay. No, Brittany's mute. Okay, perfect. Okay, so we'll see you tomorrow at 9 o'clock.
Okay.
Okay, take care.
You too. Bye.
Bye. How about that?
Yeah.